This is CIS 256. In this video, I'm going to talk about the problem set 2. So again, for any problem set, you can, in addition to coding the actual assignment, you also need to submit a document for the code reflection and pseudocode or flowchart for a key algorithms or data structure in your code. And then these are the other rubrics that you need to pay attention to. So if you click on this replit.com, you're gonna have see your own repo for this homework, right? So first you're gonna read the instructions. So the instruction is you are provided a CSV, comma separate table for the auction from a municipal government data, right? And there's two sets of data. One is the sales data, for bid sales data for December, which is a smaller set. And then there's a bigger set for the entire year. So you will use, the default is using the smaller set to do the development, but at the end you need to also test with the larger set to see how long it takes for you to sort the data by the title in various data sets, okay? And the Python code provided some starting code to load the menus. Menu include load bits, displayed all the bits, selection sort, and quick sort. That's the two main sort algorithms that you can implement. So in your code reflection and in your the flowchart or pseudocode, you're focusing on how the details of the steps in order to complete these sorts, okay? And so basically for the selection sort, it is very simple, right? So basically you go through the item in the list, and from the beginning to the end, for each position, you want to pick the minimum item from the whole list and put it in the first position. And then you move on to the second position and you pick the second smallest item and put on that position. At the end, you only have one biggest item left, and you hence you sorted everything in ascending order. Of course, you want to sort the other way. You want to pick the biggest item instead, okay? For the quick sort, there is a recursive algorithm where you basically idea is you partition that data set probably in the middle into two categories. One is item that's less than the, so you pick a pivot number. It can be in the beginning, in the end, or the middle, and randomize it. Anyway, you pick a pivot number. That number, you want to find what is the final location of that number in that list, right? So so basically, what you do is you use a partition function to find what is the final position of that pivot number. Now, usually when you pick a pivot number, you can pick the first item or the last or the middle. Typically, I put the middle, and I'm gonna move that middle to the beginning and exchange that data from the beginning. So I'm gonna look through the rest of the list, except the first one, which is the pivot number. And so I have a 2-pointer low and high, and keep increasing low if that number pointed by the low is less than or equal to that pivot number, right? So that means it's already in a left category, which is in the right position, until there's a number that's greater than the pivot number, and then you stop. And same thing from the high pointer, you go downwards. If the number pointed by high pointer is bigger or equal to the pivot number, you keep moving left until it's not. So now when the 2-pointer stopped, your lower pointer and higher pointer will be pointing at the number that is out of place, right? So the left side should be always less equal to pivot number, and the right is greater equal to. And if they stop, that means you have to, you can fix that by swapping them. And then you continue until your right pointer or high pointer is now begin to equal to the low point, right? That means they meet in the middle. And where the high pointer points is the final position for that pivot number. And you can just exchange that pivot number with the first item. So now you are done. Okay, so that's the idea behind it. Now let's implement it here. Okay, so first of all, you want to look at some data. Okay, I think there is no CSV file in this. I probably need to import the CSV files. Hold on a second. So I'm gonna load the CSV files. Sorry. Open upload file, and a second. Okay, I'm gonna go to desktop and load these two files. Okay. Actually it's there. Okay, here you go. So this is the sample data, which you can see it's the columns are title, ID, department, blah blah blah, and title, ID, department, blah blah blah. Right? And so when you read it, there's some techniques. So load bits are written for you, and you can see this bid object start with ID, title, font, and bid. So you can read this the columns, rows, one by one, and form a dictionary of key value pair. Key is the title, and value is that value, right? So auction ID, auction title is a key, and then you can append the value to the bits. So that's how you read it and put it into a object. Okay, so now let's implement selection sort. Okay, as I said, this involves two for loops, and I'm gonna get the size of the bits, right? Now, of course, you can optimize by if your extreme conditions, the bits are 0 length or only length of 1, you don't need to sort it, right? Otherwise, you can just say you iterate through the n list, okay? And each one you want to have a pointer points to minimum position. Initially, it's I, right? For its I. So I'm going to pick the smallest bits index position and change it with i's position, right? So j in range of I plus 1 to all the way to n. So let's see if bits j, and we sort by what? By title, right? Title is less than bits this minimum position, right? Which is default to I for now. If I find that one smaller than this, okay, sorry, there's a typo, bits. So if I find it smaller than that, then minimum position is no longer the original one. It has to point to j, right? So I'm always, so once you go through this for loop, you already find minimum position. Now, if the minimum position is not the original minimum position, is I, that means you want to exchange it. By exchanging it, you can use a Python feature. Just do this. Right, you change it with I. Okay, you can do that. All right, so that's exchange. Don't forget some comments. So now you did one for one round and so on. So let's test it. You have to name it to main.py. Okay, so we can just run it Python. Replit is like if you have a main.py, it will run it. Otherwise, you have to give them a solution. Comma. In range. Yeah. All right. But again, so first for load bits, you can see that it gives some stats, right? And then display all the bits. These are the IDs, title, and I can selection sort. And then display it again, you can see this MNOPQSTU WXYZ, right? So this is sorted by the title. All right, so that's selection sort. Now let's run it with a bigger data set. Okay, so I'm gonna do pass equal to the pass of the ebit file. So this is a bigger set now. As you can see, this is much bigger data. It takes a while to display all of them. Okay. Wow. And then selection sort. Sorted. All right, it's sorted. See how long it's gonna take. And because it's n square complexity, right? It's gonna take a while to finish. All right, it's finished, and then display it, and you can see this is probably sorted by the title A B C D, and then E F G H I. Okay, cool. So now while it's doing that, let's do quick sort. So again, there is two functions. One is partition, which is find the final location for the pivot value, and then this is the helper function to help. Let's do the helper function first. So again, the base case is first of all, get the length of the bits, right? So now if the n, let's say that's equal to 1, that means it's either 0 or one item, you can just return. There's nothing to sort, right? It's one item, you're just done. If begin is greater than n, that's nothing to worry about, right? Greater equal to n. All right, so now recursively sort low partition begin to mid. So we have to get the mid. The mid, which is a pivot, is equal to partition. You call it partition function with the bits begin to end, right? Now, once you get a position, well, actually this one is going to be here. Recursively call partition. So partition bits. So from begin to mid -1, and then partition of bits mid +1 to end. Because the mid is already taken care of, so you don't need to worry about that. Actually, this is not partition, sorry. Quick sort, right? So you want to quick sort left and right. Because partition is already in position, you can. So every time you do this, you reduce the number by 1, right? Quick sort 1 and 2. All right, so, okay. Begin to mid. I guess you can include the mid, no problem. Yeah, begin to mid. And now we're gonna do the partition. So you want to follow this hint, right? So let's set low and high equal to the begin. And then I'm gonna do begin +1, and you're gonna see why. Pick the middle element as a pivot. pivot equal to so middle is begin plus end minus begin divided by 2. Why I'm doing that? Think about it, all right? Especially in C++, this is important. In Python, not so much. So pivot value is the bits of pivot index, right? All right, so now we're gonna exchange pivot with low because I want to get it outside the way. Again, this is a technique in Python. Otherwise, you need a temporary variable to store, but Python can directly exchange them. That's nice. No third variable needed. So pivot and begin. So we move the pivot number to the beginning. That's why the low and high begin +1. So the pivot is not involved. So while not done, we're gonna set done to false, right? Not done yet. So what we're gonna do, keep increment low, because we want to see if the number is in place. The low has to be less than equal to high, right? That's the boundary. And the low bits, okay, its title, we sort it by title, is less or equal to pivot value of title. So if that's the case, that's fine. It belongs to that condition. So we just increment low. Same thing. Let me just copy and paste for the high. So it's high greater than equal to, and high greater than equal to low, high minus equal to 1. So high and low all meet in the middle. So here, if there are 0 1 elements remaining, so if high is less than low, what do you do? You set the flag done equal to true. I'm done, right? High is less than 0. Else we're gonna, oh, not this else, this else. Else we're gonna swap low and high, right? Begin high, not low and high, begin high. We want to put the pivot value to this final position, right, which is high. Okay, once we done that, we can return. I'm sorry, not begin, sorry. This is for the other thing. We're gonna do bits low, bits high. So we're gonna exchange this low and high, okay? Sorry, bits high, bits low. So we're gonna exchange low and high because these are two out of order, right? And then after that, we're gonna continue by doing like low plus equal to 1, high minus equal to 1. So we're gonna continue to move this. After you swapped, you can continue move on. Actually, you don't need that because this to while loop will take care of it. And at the end of the while loop, when you're done, don't forget, this is important. Your pivot value is at the beginning, right? Because at the beginning, your pivot value is exchanged with the pivot. The begin value is exchanged with pivot. So begin with has a pivot value, but you have to put in the final location, which is a high, and return the index of the final location high. All right, so that's for the entire algorithm. Okay, now don't forget to drive it, because this is a function qsort and partition, but eventually is a quick sort. The quick sort, okay, you can do the beginning of bits from 0 to length of actually n minus 1. Right? N is the length of the well, didn't say length of bits minus 1. Okie dokie. So let's run it. Python solution dot py. Oh, all right. There's some syntax errors. Well, not done. Yeah. Okay. All right. So load all bits, display all bits, quick sort. Oh, maximum recursion is low titles. All right. Let's see. This quick sort is a little tricky, but low, high, begin, end. Okay. Pivot is begin plus end plus begin. It's pivot, okay, and then exchange. Pivot with low, pivot, begin, pivot. All right. So this still good. Done's false, but not done. And I'm gonna just do low, that's equal to high, and bits high type. Oh. Yeah, right. Low, bits low title, that's equal to pivot. The title, low plus 1. And if y high greater equal to low, and bits high is title is greater or equal to pivot value dot title, high is -1, and if high less than low, down equal to true, else bits low, bits high is bits high, bits low. So far so good. And then we're gonna swap this. Bits begin, bits high, and high in begin. So that's, excuse me, final position. That's for the partition, right? Yeah, that's for the partition. Is it high? Yeah, okay. And then quick sort and equal to bits, length of bits, and return if begin with equal to end, return. And then you got mid partition bits begin to end. Sort. I guess that this is mid -1. Okay. Because mid is already sorted. And then that's the only thing I can think of, may be different. So let's try it again. And then load the bits. Yeah, quick sort. All right, so you can see it's very quick, right? But this is a smaller set. Let's do a bigger set and compare the time. Okay. Selection. Well, let's do quick sort first. Oh, that's pretty quick. And let's see, sorted. Yeah, it's sorted. And if we do selection sort, you can see it takes a long time. So that's when the data set is very big, that's when you can see the difference in n squared algorithm versus n log n. This quicksort is n log n, typically. So this is the key. You have to begin to n minus 1. Otherwise, I guess the recursion will never end. And 9 is exit. Okay, so that's all for some explanation of the homework. Hopefully you know what to do. And there's also some very nice code about like the decorator pattern. This is called decorator, which is the wrapper around the functions. So basically you put the load bits function into this decorator. See, the function is parameter, and basically the star kwrx key value pair basically capture all the arguments from the function, because I don't know how many pair parameter there, and then I added the starting time and end time, and I'm just calling that function with its original and get a result, and then save it to a log, time log.txt. So here, if you look at the time log.txt, you can see all this time spent for different operations, okay? And then you can compare, right? So whenever you want to time it, you can just do @log time. You can also @log time here. Then you can time selection sort and add @log time here. And then if you run it by Python solution.py ebit.csv, -p. You need to do -p. Okay. And then load the bits, display all bits, right? It's gonna take a while, display all bits. Now, what I'm gonna do is selection sort. Okay. So take a while. There will the print time. If not, it's at least in the logs, right? Oh, don't forget to put your first name and last name here. So you can see the time spent 12 seconds versus the quick sort is only 0.17. Wow, that's 100 times slower for the selection sort. Okay, so that's all for it, and have a good day. Bye.